Oh, say, we're continuing here. This is part 3 of the heat lecture. 1, 2, 3. And we're finishing up talking about this Q equals MC delta T. And again, it's the heat required to warm up or cool down a mass of material, a certain change in temperature based on its C value, specific heat value. And that's what we finished up talking about. Excuse me. Specific heat is sort of a temperature inertia. Again, that's not in the book. That's my way of thinking of it. If it has a big C value, which water has one of the highest, it means it's going to be slow to heat and equally slow to cool off. And we see that here in the wintertime. If you go down to the ocean, it's taking the ocean some time to cool off from the summer. It stays fairly warm through September and October. And again, come springtime, the water will still be cold up through April, May, and June because it has such a high specific heat value. There's also a whole lot of it too, so it takes a whole lot of energy to do that. But then things like heat sinks, which are used in computers to draw away the heat from things and to exhaust the heat, has a small value. If you have baseboard heating in your house where the hot water goes through, the hot water maintains the heat, heats up the metal. The metal, since it has a low C value, will heat up quickly and it will cool off quickly, meaning release it to the air. Okay? Now air has a really small C value also, so if you have a heat pump where it's forced hot air, you probably feel warm when the heat kicks on and the hot air is blowing out, but as soon as it stops blowing, it seems like it cools off fairly quickly. So one of the best types of heating systems are the old steam or hot water radiators, those big cast iron radiators. So that's a C value. So how can we look at this? How does this help us out? Well, if we're just trying to look at how much heat it took to warm 10 kilograms of water 20 degrees centigrade, we would say Q equals MC delta T. It would be 10 kilograms, 4186 for the C value, and the temperature. We don't worry about what the temperature initially is or final. We just say the change in temperature was that much, and we put it in there. Okay? It changed by that much. We're not concerned about where it started or ended. It just changed that much. And if we go through that value, there's going to be 1, 0 there, 2, 7, 3. I think it's 837, 200,000 joules. I'm sure someone will tell me if that's incorrect, but that's how much energy I would have to add to raise the temperature 20 degrees. Now, if I wanted to reduce the temperature of that much water, 20 degrees, I would just remove that much. And the way I remove it is to surround it with something or add something that's colder than it to draw that heat out. Okay? Now, if I did the same thing looking at metal, see if that color will come up, and we're talking about an empty vat, we would put in, if it was a metal one, we put 450 in there, and it would come out to be a much smaller number, somewhere around 700 and I'm not sure what it would come out to be. Well, 900. 90,000 joules. A lot less energy needed to warm up just that metal. And we see that when you're trying to boil water. If you have an empty pot on the stove, it will heat up very quickly. If there's water in it, it takes a lot more time and energy. Why? Because you're heating up not only the pot, but also the water contained in the pot. So if we had a 10 kilogram pot with 10 kilograms of water in it, it's a heavy pot. The amount of heat to heat both those up 20 degrees would be just adding these two numbers to give us the Q total. Okay. Now this is a pretty easy problem, and we're going to start with this again in a lecture on Tuesday. But understand, this is kind of valid as long as I don't heat up the water till it starts to boil, or I don't cool it off until it starts to freeze. I'm okay. So this is valid between sort of while it remains in the same phase. Now the same phase means it remains all solid or all liquid or all gas. It will not apply when we go across those. So we'll get to that in the next one. See you.